remember, when we talk about Euclidean geometry, we're talking about absolutely everything you've learned since grade 7. So we're not just talking about what you've had to learn in grade 10, which is mainly quadrilaterals. We're talking about absolutely everything. Let's start from the very beginning. We're talking about things like angles on a straight line. So we know that x plus y, we know that x plus y must equal 180 degrees. So those kinds of things we must know. We must know that the interior angles of a triangle, so x plus y plus z, x plus y plus z is equal to 180. We also need to know about the exterior angle of a triangle. Let's try that again. Okay. I'm going to do this quickly. I know that if this is A and this is B and that's C, I know that A must equal B plus C, and that is the exterior angle of, no, yes, Jaden, they are, and it's not a dumb question at all. They are. So if you go onto our class Teams, sorry, onto our Google Classroom, and you click on, I just can't remember what it is right now, but I think where you get like all the quizzes and things that we've done, it's one of the tabs at the top. There is a section that will lead you to all our videos. Okay, so don't stress, it's there. Okay, but if you want to, you can just go to YouTube and type in MathsLive and you'll find us. Okay, so don't stress. All right, so we start here. Okay, everything else that we know, all the different types of triangles that we know that there's an equilateral triangle where we have 60-degree triangle, 60 degrees everywhere, 60 degrees. We also know isosceles triangles, and we know that this and that should be equal if those two sides are equal, and we need to know the reason for that. It's angles opposite equal sides, or sides opposite equal angles, depending on exactly what it is that we're doing. So all of that is also quite important. Then we need to remember, we've learned about congruence. Triangle ABC is congruent to triangle DEF. We have also learned about similarity. We also know that triangle ABC could also be similar to triangle DEF. Now, all of this information comes into what we are doing here. So everything that you've learned before about angles, about triangles, basically all the geometry you've learned since grade 7 is going to come into play here. So we cannot pretend that we're just learning something new. No, we are taking all the information that we already know and we are putting it to use, improving things in grade 10. Thumbs up. Does that make sense? Is everyone with me here? We are taking everything and adding it together to make up what we need to know. All right, so let's look at our first question over here. It says here, in quadrilateral A, B, C, D. Now, when we read the information, it's very important that we are reading everything that we've been given so that we can actually make sure that we put it in there. All right, we are told that AD, so side AD is parallel to BC. As soon as we hear the word parallel, I need to think fun angles. We know what fun angles are? Yes, we've all heard of fun angles. Yes, good. We've got corresponding angles. We've got co-interior angles, and we've got alternate angles. Hello, Fortunate. Okay, all of these are fun. Remember, corresponding are those, co-interior, those two must equal 180, and alternate angles, those two must be equal to each other. Okay, so whenever we see parallel lines, that's the first thing we need to think of. All right, we are also then told that angle B is equal to angle D. So we now already know that this angle is equal to that angle, and that is also quite helpful. Now, the next thing they say, or the instruction really, is that we must prove that ABCD is a parallelogram, right? My next question might seem obvious, but do we know that ABCD is a parallelogram? Yes or no? Yes? Okay, Abu says no, and I'm getting people saying thumbs up, and I'm going to assume that they're saying, yes, we know this. Okay, Abu, you get 10 bonus aura points for understanding exactly what mem is going. Guys, we don't know. Do we know that ABCD is a parallelogram? No, we don't know. We don't know that it is, because it's our job to prove that it is. So we can't then go off the premise that we already know the properties of a parallelogram. No, we are proving that this particular shape is the parallelogram. So we can't go off the idea that this is a parallelogram. Are we understanding the difference? Yes? Okay. So if they tell us to prove that it is, we can't use the properties until we prove them. If they said ABCD is a parallelogram, lovely, then we can use we can use the properties. But for now, we don't know that. So we need to figure out another way to find that out. Okay, so here's the first thing we're going to note. We can see that this is a parallelogram, but what is this parallelogram made of? What is the parallelogram made of? It's made up of two other shapes.
2 triangles.
That's it. Amazing. Well done. Good. It's 2 triangles. So if we ever had to prove that this is a parallelogram, we're going to have to use the 2 triangles. Now, when we are looking at our 2 triangles, we know that in order for us to prove that it's a parallelogram, we would need to prove that sides are equal. We would need to do something like prove that sides are equal. We would also need to prove that angles are equal, right? And we're not going to be able to do that using similarity, because in similarity, my sides are not going to be equal. So instead of using similarity, I'm going to have to use congruence. Does that make sense? Are we together here? Okay, I have to use congruence because in order for me to prove that the sides are equal to each other, I need them to be identical. And the only way they're going to be identical is if I prove congruence. So let's get into our proof, right? So we will start by saying proof. Okay, dot, dot. And then I need to map my triangles out properly. Watch what I'm going to do. I'm going to say in triangle, then I'm going to say triangle A, B, C. Now, the reason I'm doing that, triangle A, B, C, is so that I remember exactly what kind of path I used. Now, I started at a corner with a large angle. I went past the small side and then the long side, the short side and then the long side. So when I map out my next triangle, I need to start where there's a big angle, go up the short side, and then the long side. So my next triangle would need to say in triangle ABC and triangle. Does anybody want to give me the mapping of the second triangle? Triangle. Okay. I'll do that again.
ABC.
It can't be ACD, ABC. We've got ABC, and that's it, Sally. Good. That it would have to be C, right? The big angle past the short side to D, past the long side to A. So my next triangle needs to read and triangle C, D, A. All right. Because this is a triangle, I need 3 reasons in order to prove congruence. So 1, 2, 3. All right, where can we start? Okay, Abu, first one. Nope, unfortunately not. We're not going to be able to do that one. Okay, we're not going to be able to do that one. What we can say is that angle B is equal to angle D. What's my reason for saying that angle B is equal to angle D?
Given.
It's given. Good. They gave it to us. There it is. They've given that to us. Good. So that's our first reason. We're going to say it's given. All right. What else have they given us here? They've given us parallel lines. So let's see what we can do with the parallel lines to figure something out. And Abu, in this particular one, you are correct. We can draw an N for fun, which is alternate angles. So what we then find out is that angle A2 angle A2 is equal to angle C1, right? And our reason for this is going to be alternate angles. And I must name my parallel lines. AD is parallel to BC. I need to name them. I'm just going to go see this one somebody else has written here. BC is equal to AD. No, Javiso. We can only use the fact that BC is equal to AD if they've given us that information. What you're giving me is the property of a parallelogram before we've proven that it's a parallelogram. Am I making sense? So first we need to prove that it's a parallelogram, and then we can say that. But this one doesn't count. Okay, we can't say that BC is equal to AD. They didn't give us that information. So no, we can't make that assumption. But Abu is indeed correct. Okay, Abu is correct. AC is what? AC is what? Good. Good, Theo. AC is a common side, right? So we can say AC is common. And the nice thing about this one is that we don't need a reason for saying that AC is common. It's just common. Okay. Then we can say, therefore, triangle ABC is congruent to triangle CDA. Let's see how this actually helps us. I'm going to write it out over here. Triangle ABC is congruent to triangle CDA. Right. Now, the reason why I want us to map these out properly is so that we can go see exactly what it is that this tells us. First thing it's going to tell us is that side AB will equal side CD, because as soon as two things are congruent, then they're equal to each other on all sides. So that tells us that AB is equal to CD. Do you see the difference, Javiso? Only now can we make those kinds of comparisons. After we've proven congruence, then we can say that they're equal to each other. Okay, and our reason is going to be the congruent triangles. You can say ABC congruent to CDA. Okay, all right, next thing, we know that BC, which side is BC equal to? BC is equal to? To AD, good. BC would equal AD, and we can see it in the way that we've mapped out our triangles. We can say BC is equal to AD for the exact same reason that triangle ABC is congruent to triangle CDA. All right, and now that we've proven that this side is equal to this side, that side is equal to that side, and we know that AD is parallel to BC, those are three reasons. That's enough for us to say that ABCD is a parallelogram. I just need to add in here, AD is parallel to BC. That is given. Therefore, oh yes, sorry, I completely forgot angle side angle. Thank you. Sorry. No, it's not angle side angle. It's side angle angle. Side angle angle. Okay. It's side angle angle, Abu. Have a look. I'll show you. I'll show you here. I've got a side there and that angle and that angle. Also on the other side, I've got a side there and that angle and that angle. Okay, it's all good. All right, therefore, we can then conclude that ABCD is a palm. All right, okay, so let's just make sure that everybody's understood what Ma'am is saying here. Unless they tell us that something is a parallelogram, we cannot assume that the properties of a parallelogram are used, okay, or that we can use them. We first need to prove that it is a parallelogram, and then we can use the properties. Does that make sense? Thumbs up? Yes? We first need to prove that it is, and then we can use the properties of a parallelogram. All right, I want us to look at this example over here. Okay, look at this example that we've been given here. It says, ABCD is a what? They tell us in this case that it is a parallelogram. They tell us that it's a parallelogram, and they tell us that AD is parallel to BC. They tell us that BA is parallel to CD. So as soon as we see parallel, we already know that we're going to use our fun angles, either corresponding or co-interior or alternate. One of these will come up. Okay, so if we know this, then we can already tell that we're going to have to if we're going to have to prove anything, it's going to have to do something. It's going to have something to do with the angles that we're using. Guys, my English airtime is running out. I don't know. Okay, now it says, using the diagram above, prove that the theorem that states that the opposite sides of a parallelogram, okay, prove the theorem that states that the opposite sides of a parallelogram are equal. Okay, first thing I'm going to ask myself, what is this parallelogram made of? If I have to prove something, what is my parallelogram made of? Two triangles, right? Oh, not in this case, Abu. You need to look again. Not in this case. All right. So we know we can't use similarity, otherwise it's not going to be a parallelogram. So we need to use congruence. So let's start from the beginning. Who wants to map out my two triangles for me? That's not where we start. We start proof. That's where we start. And then we map out our two triangles. Okay, anybody want to venture to map out my two triangles for me? Okay, Fulani says in triangle ABD, good. In triangle ABD, let's just follow her train of thought. So we went from A, short side, and through the middle, and then there. Okay, so we went from a big corner, a big angle corner, past the short side and through the middle. So the other triangle will then have to be CDB. That's it, Javiso, lovely. And triangle, look now I'm writing and twice. And triangle CDB. Good. How many reasons do we need for congruence? 1, 2, 3. Let me just get from you guys. Can you give me a thumbs up? Are we able to prove congruence on our own, or do you need my help? Give me thumbs up if you're able to prove it on your own. We can use this like, no man, don't leave me. It's okay. It's okay. All right. Let's start with the information they've given us. Okay. First information that they've given us. For those of you who know what you're doing, go for it. Fulani, I can already see you've got it. Abu, I know you've got it. Mandisa's already writing. I know that she's got it. Okay. So let's start with what we know. What they've told us here is that AD is parallel to BC. So let's go see which fun angles we can use here. I can draw an N. I can draw an N like that. What conclusion do I reach? I reach the conclusion that D1 is equal to B2. Right, good. And that's the exact reason. Good. B1 is equal to D2. Right, our reason is alternate angles. And remember, you must always name your parallel lines. Otherwise, they're not going to give you the mark. Okay, I then have to say AD is parallel to BC. Lovely. Okay, that's one set. That's one set of parallel lines. Let's go see why they've given us the other set of parallel lines. Let's go use those. Okay, let's go this way. There, I draw another N in this direction. And what do I find? I find that B1 is equal to D2. I think I wrote this one wrong. I wrote this one the wrong way around. It should have been B2 is equal to D1. And in this one, I find that B1 is equal to D2 for the exact same reason. But this time, look at the parallel lines I've used, right? It's alternate angles, but this time I've used AB and DC. So I can then say AB is parallel to DC. All right. And that's what we've used so far. All right. What else do we have? Because we need 3 reasons. There's one more reason missing here. What are we going to find? What do we notice? Khulani mentioned it at the very beginning. Good, Khulani, that's it. BD is common. BD is common. BD is in both triangles. Right, good. So we can say BD is common. I know some of your teachers want you to say BD is equal to DB and your reason would be common side. You're allowed to do that. I don't particularly think it's necessary, but listen to your teachers. We can just write BD is common, means the exact same thing. All right, so this is the conclusion we've reached. We've reached 3 conclusions. Therefore, triangle ABD is congruent to triangle CDB. Let's go find our reason for congruence. I'll show you here. If I map across this line here, I know that this angle is included in my proof and that angle is also included in my proof. So my reason is going to be angle, side, angle. Okay, on the other side, it works as well. Because that is my common side, I know that D1 is included in my proof and B1 is included in my proof. So that is angle, side, angle for both. So my reason for congruence is ASA. Angle, side, angle. Okay, it's okay, Abu. It takes some practice. It does. All right. Okay, now that we've proven congruence, that means our sides will have to be equal because that's what congruence means. It means that the 2 triangles are identical. So I can then go in and say, therefore, AB is equal to, what side is AB equal to?
To DC.
That's it, to DC, lovely. For the reason that we're looking or thinking of, CD, all right. And we can also say that AD is equal to, AD is equal to which side?
CB.
CB, lovely, CB. And there we go. We've proved exactly what they wanted us to prove. We are proving the theorem that states that the opposite sides of a parallelogram are equal. And that's true. Because they told us that this is a parallelogram, we already know that it is a parallelogram. We just needed to prove that the sides are equal. All right, thumbs up. How are we feeling about this? Are we doing okay? Yes, I'm glad, Bikanyo. Good. Good. I don't want to leave anybody behind. If I need to explain anything else, I'm happy to, but this is how we go about it. How do we prove that quadrilaterals or the properties of quadrilaterals? Most times it involves congruence. All right, let's have a look at this one. This one is a little bit hairier, but let's go and read the information we've been given. We don't panic. We first read and then we panic. We can panic after you've read the question. Okay. Let's read the information we've been given. Okay, it says here, in parallelogram, how does that help us? Okay, how does that help us? We already know that it's a parallelogram, right? And that helps us quite a lot because if it is a parallelogram, then we can already use the properties of a parallelogram. Let's talk about it. What properties of a parallelogram do we know? We know that opposite sides are parallel, which is lovely, okay? But they're talking about parallelogram PQRS. So PQRS, what this tells me is that PQ is parallel to RS. That also tells me that PS is parallel to QR. What else do we know? What do we know about parallelograms, guys? Opposite angles are equal. Good. So I know that the whole of S is equal to the whole of Q, and the whole of P is equal to the whole of R. Good. The interior angles equal 360. Okay. Opposite angles are equal, or opposite angles, as Javiso says. What else? Well, we don't need diagonals, but you're quite correct. We know that the diagonals bisect, which is lovely. Okay, what else do we know? What do we know about the sides, guys? What do we know about the sides of a parallelogram? The diagonals bisect each other. Good. That's it, Javi. So the opposite sides are also equal. That's it. So PQ is also equal to RS. I know that PS is also equal to QR. That's also some very important information that we need to know. Okay. Very, very important that we know that. Okay. Let's read the rest of the information. It says here, PW bisects QPS. All right. Do we know what bisects mean, right? Bisects mean it cuts the two in half. It cuts a line in half. So it says PW bisects QPS. Okay, let's follow that. All right, so it's bisecting an angle. I hope we're looking at this. PW, the line PW bisects the line QPS. Do we notice how the little cap, the little kapiki is on the P? You see that? So what we're going to do now is we're going to follow this particular line that they give us, and we're going to find the angle P that is made by QPS. So if I started Q, I go to P, and then I go to S there. Right. And because the little cap is on P, that means that the angle that is bisected is that one. Okay. But now, if we look at this carefully, if we know that PW cuts this in half, if P1 is equal to X, which other angle is also equal to X? Good, Abu. That's it. Excellent. Not S2. Remember, with the where they said that PW bisects that angle, which means it cuts the angle in half. So if PW's cut my angle in half, and this angle over here is X, what does that tell me about that one? That one must also be X. Does that make sense? Good, Abu. That's some really good thinking. Good. Good. All right. So it says here, oh, sorry, we're not done. Okay, and then it says, so we know that PW bisects QPS, and then it also says that another line bisects another angle. It says the SW bisects PSR. So let's follow PSR and see where it's bisected. Okay, so start at P, go to S, go to R. Okay, and the kapiki is on S, so that means this whole angle has been bisected by SW. So what does that then tell us? It tells us that S2 is equal to S1. Good, Theo, which means that S2 is also equal to Y. They're both equal to Y. Okay, I just want to make sure. Give me a thumbs up, guys. Is everybody understanding what's just happened? Are we all okay with what ma'am has just explained? I don't want to leave you behind. Okay, all right. Let me explain this again. All right. So let's say, for instance, I've got a line, right? My line AB. If I tell you guys that line CD bisects AB, that means if I draw my line CD, the word bisects, bi means two, right? It means two. Sects is like from a sector. So it cuts my line into two sectors. But these two sectors are exactly the same length. That one is equal to that one. Does that make sense? Are we okay there? Yes, thumbs up. Okay, good. Sorry, I just want to hold this up. Okay, but what that also means is that if I have an angle, like that, and I name this A, B, C, and then I tell you guys that BD bisects angle ABC, right? This is the angle ABC. You see that? ABC. If I follow ABC from A to B to C, like that, the little cap is on B, which means B is the angle that we're focusing on. Now, if I draw BD like that, That is BD. If I tell you that BD bisects the angle ABC, what that means is that we've taken this angle and we've cut it in half. So if this whole angle was 80 degrees, BD has cut this into 40 degrees and this part into 40 degrees. Does that make sense? Are we all okay there? Okay, lovely. So now, let's say I tell you, oh, look at what I've done now. All right. Let's say I say to you that BD bisects ABC, and I tell you that AB, not ABB, ABD, if I tell you that this side over here is equal to 50 degrees, if BD has bisected ABC, what does this tell me about that side there? That side there must also be
50 degrees.
50 degrees, lovely. So this side must also be 50 degrees. Okay, but now if I tell you that BD bisects this line here, and then I tell you that this side is X, what does it tell me about this side? That side must also be X. Okay, it must also be X. And that's exactly what they're telling us in this particular question here. So they say to us that the line PW, let's go and find PW. There's PW. PW bisects QPS. Now remember when we said ABC, let's map out QPS. There's QPS. Now that means that angle has been bisected. And if this side is equal to X, then this side must also equal X. All right, let's keep reading more information that we're given. We are also told that SW, let's go and draw line SW. There is SW. SW bisects PSR. Let's go and map out PSR. There's P to S to R. That angle there. And now I know that this angle has been bisected. So if this side is equal to Y, that side is also equal to Y. All right. Are we all on the same page? Yes? Amazing. I hope everybody's with me here. Okay. Cool stuff. All right. So those are the two conclusions we've reached. We're not quite done. The next thing they tell us is that PW is perpendicular, I'm lying, is parallel. PW is parallel to ST. As soon as we hear the word parallel, we need to think fun angles. So either co-interior, corresponding, alternate, one of those is going to come up, right? And we're also told that PT is parallel to WS. Okay, so that's some good information that we've been given over there. And now let's get into the proof. All right. So it says here, prove that X plus Y equals 90 degrees. All right, let's go and find X plus Y. Okay, there I've got an X over there. Here I've got a Y over here. But the problem that I'm having is that I've got two of them. Yes, I've got two X's and two Y's. Yes, thumbs up. Is everybody understanding what I'm seeing? Yes, I've got 2X. I've got 2X and I've got 2Y. I can't just take X and Y on its own. I've got 2X and 2Y. All right, let's see what this 2X and this 2Y is connected to. Right, I can see here that my two X's are connected to PQ and my two Y's are connected to RS. Right, and from there, both of them are connected to PS. Yes? Are we all okay still? Okay, now let's look at what connects these two. What connects these two sides? Okay, does anybody see it? Does anybody want to tell me what you notice? What kind of shape have we drawn? Remember the information that we've been given. What kind of shape have we drawn? Yes, that's it. Who said that? Was that you, Tiro?
Yes, ma'am.
Ah, amazing. Good. It's co-interior angles. Lovely. Because I know that PQ must be parallel to RS. That is the property of a parallelogram. So when I start this proof, 8.1, I'm going to start by saying PQ is parallel to RS, and they can't even deny it. And our reason here is because the opposite sides of a palm are parallel. Okay, that is a straight up fact. We can't do it because they told us that PQRS is a parallelogram. All right, we don't have to prove it. They've already told us it is. Good. Then I can say, therefore, x plus x is going to give me 2x plus y plus y, 2y. What must these two equal when we put them together? 180. Good, because it's co-interior angles. Good. So 2x plus 2y must equal 180 degrees. Our reason, co-interior angles, and PQ is parallel to RS. Amazing. Okay, good. Now, we don't want 2x plus 2y. We want x plus y. So I'm going to take out an HCF. Do we see it on this side? I'm going to take out an HCF over here. All right, good. An HCF of 2. I'm going to take 2 out, and I'm going to have x plus y is equal to 180 degrees. And then I'm going to divide both sides by 2. Divide by 2. Divide by 2. Therefore, there we go. X plus y must equal 90 degrees. And look at that, a free 4 marks. They've given you 4 marks. There we go. Okay, nice and easy. Nice and easy, lemon squeezy. Okay. Of course, you've got to do the work. You've got to do the work. But once you see it, then it becomes a little bit easier for us to do. Okay, all right. Shall we try 8.2? Let's try and see exactly what it is they want from us. Okay. Let's see exactly what it is they want from us. I'm going to remove some of this stuff. We know it. We can add it into our own drawings. I just want to make sure that we're all clear on what we're doing. All right. The next question says, prove that PWST is a what? It is a rectangle. Now, that's very important because now we need to know the properties of a rectangle. We need to know that. Okay. It's quite important that we know that. Okay, this one is a little bit tricky, so I need you guys to stay with me. Let's go and look at PWST. All right, so there's P, W, S, and T. There we go. Yeah, those two together. Good. So what do we know about rectangles? Thank you, Tidi Malo. You didn't even miss a beat. The things we know about rectangles is that the diagonals will bisect, the opposite angle or the opposite sides must be equal. Good. These are properties of a rectangle. Opposite sides are equal, right? The diagonals, the angles must all be 90 degrees, which will be lovely. The diagonals bisect. Diagonals bisect. Good. Interior corners, all right, equal sides. And then we also know that the opposite sides must also be parallel. Op sides are parallel. All right. Okay, so that's the kind of information that we've got here. Right, so we need to somehow prove that all of these properties are true. Okay. Now, Abu is suggesting that we use congruent triangles because we've got 2 triangles, and I'm inclined to agree. Because we've been given so much information about this, we already know that the sides are parallel to each other, so we can prove certain things, right, using our parallel lines. So let's see. Let's start out by, excuse me, sure, my brain has just gone to absolute mush. Yes, thank you. We're mapping out our triangles. Good. Let's start by mapping out our triangles. Okay. So we're going to say proof. Good. Proof. Okay. In triangle, Okay, somebody give me a triangle. In triangle, PTS, okay? In triangle, PTS. So let's just remember where we started. We started at P. We went past the long side and then to the short side. So the next one must be and triangle. Where do we need to start? We can't start at P because if I start at P, I'm going to the short. Say that again.
SWP.
That's it, my darling. Amazing. I need to start where I can go past the shorts alongside. So SWP. Good. So and triangle SWP. All right, there we go. So those are my two triangles that I'm going to use. Okay. Then, as always, it's a proof. So 3 reasons. 1, 2, 3. Let's go ahead and put those parallel lines to use. Okay, let's start with, okay, we know that this is X. Let's name this one S3, that part over there, S3. So we can start with PW and ST, right? Good. We know that PS is common. Lovely, Abu. That's quite helpful in this situation. So I'm going to first say that angle S3 is equal to X. Yes? Thumbs up. Does everybody agree with ma'am? Are we all okay with that statement? Yes? There. Because I've drawn alternate angles, that angle must equal that one. Good. So that is alternate angles, angles, because PW is parallel to ST. Okay, then let's look for another reason. Okay, I love that Abu is saying that PS is common. He's not wrong. PS is common. Let's add that in there. Okay, let's add that in there. All right, what else can we prove? Okay, I'm going to name this part P3, and I'm hoping that's giving some things away. Does that give something away? Anybody got an answer there for me? Good, Abu. Let's see. P3 is equal to S1, good, which is equal to Y. Let's draw that. Let's see how that looks. Okay, if I draw that, I know that that angle must equal that angle there. So I can then say P3 is equal to Y, and that's because of alt angles. Good, alternate angles. And our angles in this case will be PT is parallel to WS. Good. We've now got 3 reasons. Okay, but I've got a problem. I've got a problem. Okay. I've now proven that PWST is a parallelogram. I haven't proved that it's a rectangle. Okay, let's finish up and then I'll explain what I mean. All right, so I can say, therefore, triangle PTS is congruent to triangle SWP. Abu, do you want to try for the reason again this time? Look at it properly. What are we thinking? Okay, I've got an angle. I've got an angle. That's the one. That's it. And I've got a side in between them. Good. On the other side as well. I've got an angle. I've got an angle and a side in between them. You make me so proud, Abu. Thank you. Amazing work. Good. So angle, side, angle. All right. So here's the problem, guys. The only thing we've really proven is that PWST is a parallelogram, because we've given it all the properties of a parallelogram. But who can tell me what is the difference between the parallelogram and the rectangle? There's one very important difference. Good. Didimalo, be a little bit more specific. What's the difference between a parallelogram and a rectangle specifically? No, opposite sides are also parallel in a parallelogram and in a rectangle. That's it. Good. I know that the interior angles of my triangle must equal 90 degrees. Each of them must be 90 degrees. So we must now prove that the angles inside PWST are 90 degrees. Let me show you how we're going to do this. All right, so let's go back to this statement that we have over here. This statement over here, right? I know that x plus y is equal to 90. Let me map out my triangle. If I map out this triangle over here, what are the interior angles of a triangle equal to? It's an easy question. Interior angles of a triangle will equal 180.
180.
180, good. But now before, what we proved is that x plus y is equal to 90 degrees. How much is left for that angle there? How much would W1 be equal to? W1 must equal? If x plus y, if those two are 90 degrees together, this one must then also be 90 degrees. Are we in agreement? Yes? Does that make sense? Okay, who's a little lost? Who needs me to explain again? Okay, all right, let's look at this. I'm going to give you a triangle. I'm going to give you the exact same triangle. Right. Same triangle. That is x, that is y. If I tell you guys that x is equal to 60 degrees and that y is equal to 30 degrees, right? That checks out because this statement says that x plus y must equal 90 degrees. Are we all in agreement? Yes. And if x is 60 and y is 30, then that gives me 90 degrees. But this thing is a triangle. What does it tell me about this angle over here? How much should this angle be equal to?
Isn't it going to
It
be
must
90
equal
degrees?
90 degrees. Of course, it must equal 90 degrees. Lovely. Okay, so now technically, I don't have to know what x plus y is. As long as I know that x and y together equal 90 degrees, that automatically makes this angle 90 degrees. Does that make sense? Wikanyo, are you with me? As long as I know that this one and that one are 90 degrees, yes, they could. We don't know that. Maybe this thing isn't drawn to scale, Abu, you never know. Right, so what we know from this is that W1, this angle over here, must be equal to 90 degrees. Okay, so let's see how we're going to write that out. First thing I'm going to say, okay. Oh, yes, very true. Yes, but Abu, remember that a square is a rectangle. So, a square is a rectangle. A rectangle is not a square, but a square is a rectangle. Okay, all right. So I can then say, in triangle PWS, I'm going to say x plus y plus W1 must equal, how much must those three equal? X plus y plus W1 must equal 180 degrees. Lovely. And our reason there is because of the interior angles of a triangle. All right. The interior angles of a triangle. Now, I already know that x plus y is equal to 90 degrees. So I know that I'm just carrying on over here because I've run out of space. X plus y equals 90 degrees. Therefore, W1 must equal 90 degrees. Okay, does that make sense? Everyone okay with that idea? Thumbs up? I hope everybody's cool with that. Okay, next thing we're going to note now is that because we've mapped out our triangles so beautifully, angle W, let me go back. Let me do it over here. Angle W must equal to which angle? Which angle must W be equal to, according to this? We've mapped out our triangles accordingly. That's it, Sanele. W must equal T. Angle W must equal angle T. Right. So I can then say that angle W1 is equal to T, which is also then equal to 90 degrees. And our reason for that is because triangle PTS is congruent to triangle SWP. Okay, and now that we've proven that the diagonals are 90 degrees, we've proven that this is 90 and that is 90. Now we can then say, therefore, PWST is a rectangle. Okay. All right. And guys, I'm so sorry. I've taken these from 2023 and 2022 November papers for grade 10. So I know it's a little tricky, but we need to know how to do this. Okay. It does get really tricky. Okay. All right. Can I show us something a little bit different? Yes. It's paper 2, Little. It's paper 2. Okay, let's look at something a little bit more different. Okay, if you want a little bit more practice, there's another question. You can take a quick screenshot. Okay, 5 seconds. 4, 3, 2, 1. All right. I just want something. Okay, let's look at this over here. All right, what are we looking at here? What part of mathematics or what part of Euclidean geometry are we looking at here? I'm sorry, Zia. I know it does get quite difficult. It does. All right. What are we seeing, guys? What am I seeing here? Which theorem are we going to use? That's it. Not the converse. We don't need to use the converse in this case. It's the midpoint theorem. Okay, I know it's a bit confusing. This one is particularly the midpoint theorem. Okay, this one is particularly, the converse would be if they had given us the parallel lines and then we added in the sides that are equal. All right, okay, just thumbs up. Who needs a reminder of the midpoint theorem? Who needs me to remind them what the midpoint theorem says? I figured we would have all forgotten. All right, so all right, the midpoint theorem says if I've got a triangle A, B, C, and I draw a line DE such that D is the midpoint of AB and E is the midpoint of AC, then I can reach two conclusions. Okay, if D is the midpoint of AB, then that means that AD is equal to DB and AE is equal to EC. Okay, that's the first conclusion that we can make, right? Good. Then we can also make the conclusion that if DE is X, BC must be 2X. Okay, conclusion number 2. Conclusion number 3 is that DE will then be parallel to BC. Okay, all of those things are important. All right, write that down. If you're taking notes, write that down because this is very, very important. Otherwise, you're not going to be able to answer these questions here as we go. All right. Okay, and give me a thumbs up when you're done because I'm going to have to erase it. I need space. I need space. Or take a screenshot or write it down. Give me a thumbs up when you're ready so I can start on the question. Oh, I see. Oh, okay. We must remember these things. We must remember these things. All right, I've gotten thumbs up, so I'm going to delete this. Okay, I'm going to delete all of this stuff. Okay, we should know what we're looking at now. All right, first thing we're always going to do, remember, we always read the information. Let's read the information we've been given. It says here, in the diagram below, D and E are, come on, guys. D and E are midpoints. Good. They've told us that they're midpoints. Right. And then look at what they've done here. They've told us that D and E is a midpoint. And then they've actually told us here that AD is equal to DB. They've done it for us. And they've told us that BE is equal to EC. Lovely. All right. Because of these lines here, that tells us exactly what we need to know. Lovely. What other conclusion can we make? What's the other conclusion that we can make, guys? If those two are midpoints. Good. We know that DE must be parallel to AC. That's what the midpoint theorem says. What else does that say? Good. We know that DE is half the size of AC. So AC is equal to 2 times DE, or DE is equal to half of AC. I just want to make sure everybody's understanding that. Give me a thumbs up. Are you okay with what ma'am has just gone through here? Okay, I hope we're okay. Okay, this is the midpoint theorem. All right. Okay, but we're not quite done. Let's continue with the information that they've given us. Okay, now they tell us here that point P is on the line BC such that PA is equal to PB. Okay, now we've got a little bit more of an extra element here. Let's go add that in. It's on the line BC such that PA, there's PA, is equal to PB, is equal to that 1, 2, 3. All right, let's do this. Let me join them. Let's join them. Let's see what they're actually getting at here. I'm going to take PB and PA, and I'm going to join them. Let's join them there. What do I have? I've got a triangle, but a very specific type of triangle. What kind of triangle do I have? Good, good. I've got an isosceles triangle. Right. What do we know about isosceles triangles? What do we know? 2 equal sides. Good. They've told us that PA and PB are equal. Good. 2 sides are equal. What else? Apart from just the 2 sides being equal, good. The base angles of my isosceles must also be equal to each other. So if I have an isosceles triangle, if that side is equal to that side, this base angle over here must equal that base angle over there. All right, so keep that in mind as we're going along because they've given us that information. So we're going to have to use it at some point. All right, then it says PB cuts DE at R. So we are told that PB cuts DE right here at R. Over there. Okay, 1, 2, 3. Let me not forget that. All right, all of that is very important. All right, now the question says to us, prove that triangle RDB is isosceles. Now, don't think that's the same triangle we were just looking at. No, no, no. Let's go and find triangle RDB. There's R, there is D, there is B. So that tiny triangle there. Okay. That triangle, we're trying to prove that that tiny triangle is an isosceles triangle. All right, let's start with what we know. Let's start where we know things. Okay, first thing we know is that triangle APB is isosceles. Yes? Thumbs up. Are we all in agreement? Is everyone with me there? Good. So my first thing that I'm going to say is that we are in triangle APB. Let's talk about what we can say in triangle APB. If I know that AP is equal to PB, what information does that give me? How does that help us if we know that it's an isosceles triangle? I know that angle A must equal what? Angle A must equal? Not B. Be more specific, guys. That's it, Abu. Good, good. Not just B, because if we said B, we'd be talking about, oh, don't know what happened there. If you just said B, then you're talking about that whole angle. No, no, no. We need to be very specific, right? We need to say angle A is equal to angle B1, right? Those are the base angles of my isosceles. So I need to say angle A is equal to angle B1, but I can't write isos. It's not allowed. I don't, okay, I'm going to be very honest, grade 10s. I don't know. At this point in time, I don't know, because some teachers tell me that we're allowed to say isos. Other teachers say we're not. I'm just going to teach you the one that's always allowed, which says sides opposite equal angles. You need to know that one. Okay, if you write this one, you are always guaranteed the correct, you're always guaranteed the mark. But if you write isos and somebody at the NSC marking decides, no, we don't accept isosceles anymore, you've lost the mark for no reason, please write this one down. This one will guarantee you the marks. Even if they accept isos, this one will 100% guarantee you the mark. All right, so here's what we want to prove. We want to prove that triangle RDP is isosceles. At the moment, what I've managed to prove is what B1 is equal to. Now, if I wanted to prove that this tiny triangle is indeed an isosceles triangle, which other angle do I need to prove B1 is equal to? In order for this tiny triangle to be isosceles, I must prove that, be more specific, Abu. Good. I must prove that D2. I must prove that D2 is also equal to B1. Thumbs up. Does that make sense? Is everyone with me there? Do I need to explain again, or are we okay there? Good. So if I want to prove that this is an isosceles triangle, I need to prove that this angle is equal to that one. But what I know is that B1 is equal to A. So I now need to somehow prove that A is equal to D2. And Abu, you are spot on. I think you just jumped straight to the answer. How do we prove that angle A is equal to angle D2? Let's look at the bigger picture. Okay, remember, they've given us a huge thing about the midpoint theorem. So somewhere we need to use the idea of the midpoint theorem. Right. Now, first thing I can say, how do I connect A to D? Which two lines connects A and D? What are the two lines that connect them? It's not going to be ADB. That's not going to help me. Good. It's going to be AC. AC is one of them. What is the other line that connects them? Abu? What other line connects them? AC connects A. Which line connects D2? Anybody? Yeah. Good. DE. Good. I've got AC and I've got DE. Those two connect each other. Okay. So I can say, what can I say about AC and DE? What do we know about AC and DE? That they're what? Yes, good. AC is twice the size of DE. Good, Sanele. That one is going to help us. That one is going to help us. First thing I'm going to say is I'm going to say that AC is parallel to DE. Okay, that information was not given to us. How do we know that AC is parallel to DE? Because of which theorem? Now, Abu, you can tell me. Of course, absolutely. Which theorem tells us that AC is parallel to DE? That's it. The reason here is because of the midpoint theorem, mid-PT theorem. Okay. Now, as soon as I hear parallel lines, I know I need to think fun angles. So can we draw a U? Can we draw an F? Can we draw an L, an N, not an L, an N, right? Let's connect A and D2. Okay, if I draw an upside down F like that, okay, what do we notice?
Corresponding angle.
That's it, my love. That's it, Buikanyo. Good. A must equal D2, right? I can say angle A is equal to angle D2 because of corresponding angles. And I must name my parallel lines. AC is parallel to DE. Okay. And now I've just proven that DORDB is an isosceles triangle, because if A is equal to B1 and A is equal to D2, then both of them must be equal to each other. They're both equal to A. Okay, then I can say, therefore, B1 is equal to D2, right? And if those two are equal, then we can get to our reason. Therefore, triangle RDB is isosceles. Isosceles. There it is. Okay, guys, I'm going to admit this stuff is kind of hard. Okay, it does take practice. Okay, it does. All right, here's a different one. But this one is ugly, so maybe we skip this one. I don't like it. I think it's a little bit too difficult. This one is too difficult. Yes, and it does come from I think maybe we skip this one and we go and look at the memo and then we practice how to do it. Okay, because if we're struggling with some of the others, this one is going to be a bit tough. Okay, the nice thing about these papers that you're writing is that they always give you an easy one and then they give you a hard one. Let's maybe focus on the easy one, and then we'll come and we'll grapple with the hard one at the very end of the lesson. Yes, Sanele, of course. If you'd like to do it, of course we can. All right. Okay. So let's quickly go and see what we have here. All right. So it says here, in triangle PQR, we're given in triangle PQR, QT is equal to TU. Okay. QT is equal to TU. All right. Which is equal to UP. All right. And we can see it here. They've given it to us. They QT, TU, UP. All right. Great. What else do we know? We're also given that QS is equal to SR and UV is equal to X centimeters. All right. Okay, let's see what we can do with this. It says, determine the length of VR in terms of X. So they want us to determine the length of that part there in terms of X. Okay, so what we do know is that there's going to be a couple of things here that really do help us. Okay, first thing I'm going to do is I'm going to map out a triangle that will allow me to use the midpoint theorem. Okay, so here's what I'm going to do. I'm going to map out the triangle with VR in it. So I'm going to go UR to UQ to QR. Thumbs up. Does everybody understand why ma'am has picked that one? Do you understand why ma'am picked that one specifically? No? Okay. Remember what the midpoint theorem says. The midpoint theorem says if I've got a triangle like this and I've got a line that cuts it in the middle there, then I need this side and this side to be equal to each other, and that side to be equal to each other. Now, look at the way ma'am has mapped these out. I know that this one must equal that one, and I know that that one must equal that one. What does that tell me then about TS and UR? TS and UR must be what? Good, good. I know that TS and UR must be parallel to each other. Is that making sense, Biganyo? Are we okay there? Okay, I need to make sure that I map them out properly. So I know that TS must be parallel to UR, and I know that TS is half of UR. Okay, all right, let's see how we can connect these two things together. Sure, and this one is quite a tough one. Okay, so in triangle UQR. Good. In triangle UQR, Okay, what conclusion have we reached? We've reached that TS is parallel to UR. Okay, and our reason there is because of the midpoint theorem. Okay, all right, how else does that help us? We know that TS is parallel, is parallel to UR. What else can we say? PV is equal to VS. Say that again, Abu. Let me see your explanation there. Oh, I see. That is it. Okay, cool. All right. So we are getting somewhere. All right, good. Okay. Then what Abu does next? Yes, good. Then we just need to map out the next triangle, right? We're going to go in triangle. Now we need to use triangle PTS. We need to use that triangle. That one there. Okay. Now, what we've just discovered is that this is parallel to that. Okay. We know that that's parallel to that. So in triangle PTS, we know that TS is parallel to UV. It's been proved above. We proved it right above there using the midpoint theorem. Okay. Therefore, we know that PV must equal VS. Okay. And that is the converse midpoint theorem. Okay. But Abu, that's not going to help us as much as we think. Okay. Let's think about this. Actually, no, you're quite right. Mid-PT theorem. You're quite correct. But we're just not going to reach that conclusion. Okay, if we reach the conclusion that PV is equal to VS, what that then tells us is that UV is half the size of TS. Right. So if UV is X, TS would need to equal how much? If this is X, that must equal 2X. Good. All right. So now I know UV is equal to, no, not UV, sorry. Therefore, TS is equal to 2X. All right. But now let's go back to that big triangle that we were using. Let's go back to triangle UQR. If I go back to UQR, that big triangle, I know that this is parallel to that. And if this is 2X, then UR must equal how much? Not 2X. This is 2X. That one must be double that. So this angle from there to there must be 4X. Good. UR must equal 4X. So if we know that the distance from there to there is 4X, we already know that that part is X. What does that tell us about VR? Therefore, VR must equal 3X. That's it. VR must equal 3X. I'm going to put you all out of your misery